Alright, so today we are learning 7-2 similar polygons, and our essential question for today is how are you going to know how to use similar polygons to find unknown sides and angles? So we're going to look at how the polygons themselves help us determine things that are missing on other shapes. So our first thing we need to understand is the definition of a similar polygon. Definition of a similar polygon says two polygons are similar if their corresponding angles are congruent and the lengths of the corresponding sides are proportional. So again, we're back to that proportional aspect of what we learned in 7-1 with ratios. So the symbol that means similar to is a lovely tilde. So remember that. We're going to be using that and you'll be seeing it in examples. So our first example is we would like to compare similar triangles and see if we can explain it. Okay. So we have to first kind of see that this is ABC, triangle ABC, and DEF. We can see that the smallest number correlates with this smallest number, the middle number, and the middle number, and the large number, and the large number. So what we need to do is determine, well, are they similar? So we need to compare them. So what we can see here is I'm going to look at AC over DF, and I'm going to see that 3/6. We can simplify 3/6, which is our ratio, to be 1/2. I now need to do this for the other sides. So we're going to go CB over FE, which is 4/8, which is the same thing as 1/2. So starting to look pretty similar. We have AB over DE, and we see that it is 5/10, or the same thing as 1/2. Hey, they're all the same number. This is a really good sign. Again, we saw that back in 7-1, proportions. So they're all the same, which means they are proportional to each other with a ratio of 1/2. So, since they have a common ratio, we know since all three of the ratios are the same, the lengths of the corresponding sides are proportional. So the common ratio is called the scale factor. So we're noticing ratios are helpful with proportions, which is helpful in similar polygons. So as a quick reminder, scale factor is the common ratio in simplified form. As above, the scale factor was 1/2. So now we're going to determine if these rectangles, ABCD, is similar to EFGH. Well, we see that AB is 22, AD is 12, EF is 11, and FG is 7. Well, since this is a rectangle, that means proportionally we can see that these have to be the same and these have to be the same. And we're going to see if these are going to be proportional to each other. So I'm going to first look at AD, which is 12. And we know since AD is in the same area as EH, we should see that 7 correlates with it. So we're going to check with FG, which is 7. So we have 12/7. And can we simplify that? We can't. 7 does not go into 12 at any point. So we need to look at 12/7. Well, now we need to see if AB and EF are going to be the same scale factor as 12/7. Well, hopefully you can see that 22 and 11 actually do correlate with each other. And it happens to be, when you simplify it, to be 2. So we have 12/7 and 2. 12/7 and 2 are not the same number, are they? Well, since they're not the same number, They are not similar to each other. So this is not similar to each other. So we have to look at all lengths. So remember, as you saw in example 1, when we went through, you saw that all the numbers were the same. You have to check all sides that are given to you. On this one, even though there were only 2 sides we checked, since they were a rectangle, we could tell that no matter what, we would have only 2 answers. And since they were totally different from each other, therefore, the 2 rectangles are not similar to each other. So if you are feeling pretty confident in what is being asked of you, go ahead and try number 3 for me. Take a little break. See if you can follow along or get the right answer as I go through it. So number 3 says determine if they are similar. So once again, we are determining, do they have the same scale factor? And if they are similar, what's the scale factor? So if you can figure out the scale factors are similar, then you know the scale factor. So we can see that this has a missing angle. But we notice 110, 110, 110, 120, 120. So that means this has to be 120 degrees and this has to be 80. Okay? So that right there is helpful. That means that this is similar to this one, which means these are similar to each other. These are similar to each other. And this one is similar to each other. Even though there is 5 sides, since 2 of the sides are similar to another 2, we only have to check 3 things. Okay? So we're going to first check, we're going to go with 6 over 15. Well, 6 over 15 can be simplified because they both have factors of 3. So we're going to see this comes to be 2/5. So that takes care of our 1s. Now we need to check our 2s, which is 8 and 20. So 8 over 20. Well, 8 and 20 both have factors of 4, so we can simplify that one down. And that simplifies down to 2/5, so that's nice. Then we have a third one. We have 10 over 25, which is the same thing as 2 over 5, because you can take out a 5 from each of them. Well, now that we've determined the proportions of all sides, we can see that they have the same number. So they're similar. The 2 figures are similar. And since they're similar, we can determine the scale factor. Well, scale factor is the number that you say that they all have to be. So our scale factor is 2/5. All right, well, if you can see what's going on, we got another example, one more. See if you can determine if they are similar or not. Okay, so we're gonna see one more. Try one more for me. So number 4, we're going to determine if the figures are similar. If they are, what is the scale factor? Same thing as number 3. Except now we're dealing with a triangle. Since they all have sides and 2 angles, you should be able to figure out the third missing angle on both of them. We all know what a 90 is. We should always check angles. It helps. So, since we know 2 angles, we should be able to find the third angle by 180 minus these 2 angles. This angle happens to be 25 degrees, and this angle happens to be 56 degrees. Interesting. Are the angles the same? Well, they're not. So if angles do not match, they are not similar. So, when in doubt, if you're given angles of certain polygons of any sort, make sure that you're checking them to determine if they are similar or not. Well, just for practice, we are going to determine side lengths. Just in case. You never know. But we're going to look at side lengths now. Again, like we've been looking at them. So we're looking at side lengths. So we can see we're going to go by smallest. So the smallest number here is 14, and the smallest number here is 7. So we're going to look at 14 over 7, which equals 2. And then we're going to look at the next smallest, which is 17 and 8.5. 17 over 8.5 is 2. And 18. We're going to do 18 over 9, which is 2. Wow. So they do have the same ratio. So they would have a scale factor of 2 if the angles were the same. So make sure you check your angles. But again, this is really good practice. You are pretty much doing this on your homework. I don't think there's really too many angles, but this is what you need to look at. You need to look at every side length, determine if their simplified ratio is the same to determine if there's a scale factor. Okay. All right, well, I would personally take a break right now, kind of get the thought processes moving. If not, continue on